peatland plants adapting well to climate change. Southampton, UK SPX October 31, 2017. They account for just 3% of the Earth's surface but play a major role in offsetting carbon dioxide emissions, and now a team of scientists led by the universities of Southampton and Utrecht has discovered that the plants that make up peat bogs adapt exceptionally well to climate change. In a study published in the journal Nature Communications, experts show that, even though certain species in a peat bog's plant community might disappear because of the effect of rising temperatures and increasing levels of atmospheric sulfur and nitrogen, their place will be taken by other species with different environmental preferences but a similar biological function. Compared to more diverse plant communities, such as dunes and grasslands, peatlands have been observed to lose fewer species as a result of climate and environmental changes. As high species richness helps ecosystems perform their functions, e.g. carbon uptake, this could mean that peatlands' carbon storing function is resistant to climate change. Marshy and rich in vegetation, peatlands play a crucial role in the Earth's carbon cycle. Globally, they store more than 500 billion tons of carbon, representing 16% of carbon in all terrestrial ecosystems and equivalent to 67% of carbon in the Earth's atmosphere. The International Mire Conservation Group has said that protecting peatland could offset up to 10% of global carbon emissions. Peatlands also act as a sponge in the landscape, holding large amounts of water on which many other ecosystems rely and which provide us with 70% of our drinking water, a role set to become ever more vital with the predicted increase in drought events. Lead author Dr. Bjorn Robroek, of the University of Southampton, visited 56 peat bogs across northern Europe, including the UK, noting the species that grow there and analysing the relationships between the species, the local climate and the atmospheric composition. The data showed clear differences in vegetation between individual peat bogs, but similar levels of biodiversity, the number of different species in the area. Further analysis revealed that, in each bog, these species could be divided into two clusters that usually grow together, one group of plants that thrive in higher temperatures and precipitation, the other that do well in lower temperatures and less precipitation. As the plants in the two groups have similar biological functions, the results indicate that bogs can continue to function properly even with changes in the composition of the plant community. Dr. Robroek, who led the collaboration involving universities across Europe, said while studies of other plant communities have shown that environmental change has a negative effect on species richness, the effects on peatlands seem minimal. In other words, peatlands seem rather resilient in the face of environmental change, with species replacing each other to create different compositions in the plant community. When we calculated if this also results in a change in the functional composition of the community, in other words, the composition of the plant community based on a set of plant attributes that are linked to functions, we were surprised to find it unaffected. Joint lead author Dr. Vincent Jassy, of the University of Toulouse, France, commented that the findings do not mean that peat bogs are impervious to environmental change. Peatlands are still prone to degradation through other environmental changes, for instance, the invasion of non-peatland plant species, and human activity such as the draining of bogs can have a major detrimental effect on the plant community, he said. Peatlands store a huge amount of CO2 that would otherwise be released into the atmosphere to contribute to global warming. In addition, they provide the majority of our drinking water. For these reasons alone, protecting these environments should be high on the political agenda. Research paper: Amazonian hunters deplete wildlife but don't empty forests. Norwich, UK SPX October 26, 2017. Conservationists can be cautiously optimistic about the prospect of sustainable subsistence hunting by Amazonian communities, according to new research from the University of East Anglia. Human exploitation of natural resources is a key driver of global biodiversity loss. In tropical forests, overhunting has been implicated in widespread local species extinction and the creation of EMP. Read more related links: University of Southampton Forestry News, Global and Local News, Science and Application. Thanks for being here, we need your help. The Space Daily News Network continues to grow, but revenues have never been harder to maintain. With the rise of ad blockers and Facebook, our traditional revenue sources via quality network advertising continues to decline. And unlike so many other news sites, we don't have a paywall with those annoying usernames and passwords. Our news coverage takes time and effort to publish 365 days a year. If you find our news sites informative and useful, then please consider becoming a regular supporter, or for now make a one-off contribution. Space Daily Contributor $5 billed once, credit card or PayPal. Space Daily Monthly Supporter $5 billed monthly, PayPal only.